Hey guys, we are reviewing for your test tomorrow, your last test of the year. Aren't you so excited? All right, so let's go through these problems together. Let me back up for a second. All right, so on the first one, it says line A is represented by the equation given below, x plus y equals 2. What is most likely the equation for B so that the set of equations has infinitely many solutions? So that means that we want basically two lines that lie on top of each other. So early on in this unit, I told you if you have two equations where you can get from one equation to the next, the other equations, by multiplying every single term by the same digit, that means that they have infinitely many solutions. So I see 2x, 2x, 2x. So I know to get from x to 2x, I'd have to multiply by 2. So let's see if this is one of our choices. If we multiplied every single term by 2, we'd get 2x plus 2x. I meant 2y, excuse me. And then 2 times 2 is 4. Well, that is one of our choices. The other two don't match. And then this, all they did was multiply only the answer behind the equal sign by 2, so that doesn't make any sense. So that is the answer, letter B on that one. All right, number 2. So basically, we just need to solve the system of equations. So the best way to do it, or you have several choices. If you had a graph, you could graph them. And they're both equal to y, which means you can set them equal to each other. Or you can eliminate by multiplying one of the equations by a digit to make either the x or the y cancel. Well, since I don't want to multiply every single number in the first equation by a different number, then I'm just going to set x minus 6 equal to 3x plus 4. All right, so when we have a problem like this, we're going to get our x's together. So I'm going to get rid of 1x by subtracting x from both sides. So what do we have left? We have negative 6 is equal to 3x minus 1x is 2x plus 4. Now I want x by itself, so I'm going to get rid of that plus 4 by subtracting 4 from both sides. So 2x is equal to negative 10. And when I divide by 2, it tells me that x is equal to negative 5. That's my x value. To get my y value, I'm going to plug in x, negative 5 for x. So right here, instead of x, I'm going to write negative 5 minus 6 is equal to y. And negative 5 minus 6 is negative 11. Real quick, I'm just going to make sure that's true on my second equation. 3 times negative 5 is negative 15. And negative 15 plus 4 is negative 11. So I know my answer is correct. All right, number 3. What is the solution to this system of equations? So this one, we had two lines. They already graphed them for us. All we have to do is identify this coordinate right there. So if you start at the origin, you would go right 5. And then from there, go down 2. And that is the point where those two lines intersect. That is the solution to that system of equations. Number 4, solve using substitution. So this one is very similar to how we solved for number 2. Since these were both equal to the same variable, that means that these were equal to each other. Well, same thing here. These equations are both equal to the letter C, which means we can set 2d plus 1 equal to 3d plus 7. We're going to get those d's together by subtracting 2d from both sides. So we would bring down our 1. 3d minus 2d is 1d. And then to solve for d, we subtract 7 from both sides. So d is equal to negative 6. However, we still have to solve for c, right? So I'm going to write d is equal to negative 6. And what is c? Well, if we plug in negative 6 right here, 2 times negative 6 is negative 12. And negative 12 plus 1 is negative 11. Just going to double check it. That would be negative 18, and negative 18 plus 7 is negative 11. So I know my answer is right. So that's the answer. All right, number 5. Here we have a set of equations. How many solutions are there to the given set of equations? How many solutions? So basically, I am going to, since my 6 x's are the same, I'm going to multiply one of the equations by negative 1. So my x's will cancel. So I'm going to bring over equation C, the top one, y equals 6x plus 9. In equation D, I'm going to multiply every single term by negative 1. So I'd have negative y is equal to negative 6 minus 2. So then when I do my big plus symbol, y minus y is 0 equals 6x minus 6x is 0. And 9 minus 2 is 7. So I end up having a statement of 0 equals 7. Is that true? It's not true. That's not true. So when it says how many solutions are there, the answer is 0. There's no solutions. All right, on this one, we have a graph. So obviously we're going to solve this system by graphing. So do you remember how to graph? You start at your y-intercept. So our y-intercept is 0, 13 right up here. And we have a negative slope. We're going to go down to right 1. So from here, we're going to go down to right 1, down to right 1, down to right 1, down to right 1. Let's do it one more time. All right, and you're going to, and then on this one, we're going to start at the y-intercept 0, negative 3. 1, 2, 3. And this time we're going to go up to right 1, up to right 1. So I'm going to go up 1, 2, 1, 1, 2, 1, 1, 2, 1, 1, 2, 1, 1, 2, 1. It would go right through there. There it is. That's our solution right there. What is that solution? Start at the origin. You go right 4, and from there we go up. I can't read these numbers. Can you? 1, 2, 3, 4, 5. 4, 5 is our solution. That's where they intersect. And then just to double check, I'm going to plug in x is 4. So 2 times 4 is 8. And does 8 minus 3 equal 5? It sure does. Whoops. I'm going all over the place, aren't I? My pen keeps switching off. All right, let's look at number 7. A student is trying, I can't read it. A student is trying to solve the system of 2 equations given below. Which of the following is a possible setup used in eliminating the y values? All right, so let me rewrite it over here. I have y plus z equals 6. And the other one is 3y plus 4z equals 1. And they want to eliminate the y. Well, I'm not going to try to turn 3 into a 1, but I can get rid of positive 3x by making this one, this top one, a negative 3x. Oh my goodness, you guys, what is wrong with my pen? So how would I make y equal to negative 3y? Well, I would multiply the whole term by negative 3. And I should do that, but basically it's asking for the first step. So the first step in eliminating the y's is to multiply the first equation by negative 3, which is what this tells us to do, right? The other choices don't make sense. If I multiplied y times 4, my y's wouldn't eliminate. This would be 4y and 3y, which is 7y. If I multiplied the bottom by 4, I'm going to make this bottom one 12y. This is still 1y. That doesn't eliminate anything, right? And the bottom one doesn't make sense as well. All right, number 8, variable g is, all right, so when I see g is, I'm going to go ahead and write exactly that. G is 8 more than w. So 8 more than w. So it'd be w plus 8. This means that g is 8 plus w, or w plus 8. Variable g Variable G is also for less than W. Less than is reverse order. So for less than W is W minus 4. Write a system of equations that best models the relationship between G and W. That's it. And I just went word for word and got all of these from these words. I see the word is. I see the word more than means plus. I see G is, there's G equals. And for less than W is W minus 4. Now, just to figure out what these numbers are, I'm going to go ahead and solve this. We don't have to. We just had to write the system of equations. But since they're both equal to G, that means W plus 8 is equal to W minus 4. So if I get my W's together, I end up with 8 is equal to negative 4. So this is actually no solution. But it didn't ask us to solve it anyway, because this is not true. But now we've come up with the system of equation, and that's it. All right. Number 9, a zoo train ride costs $4 per ticket. Let me change colors. $4 for tickets for adults. Okay, there we go. And $1 per child ticket. On a certain day, there was a total number of adults and children who took the ride was 27. So the first thing I know is that there were 27 tickets sold, and those 27 passengers were adults plus children equaled a total of 27. Okay, so that's our first equation. The second equation has to do with how much money was taken in. Well, I don't know how many adults went yet, but I know that each adult paid $4. So 4 times the amount of adult tickets plus $1 times the number of children's tickets had to equal $60. So this is about the number of tickets. This is about the amount of money. So we're going to write. So first of all, that is our system of equations. That's what it looks like. And now we're going to solve it. So since my C's match, I'm going to go ahead and multiply the top one by -1 so I can cancel out my C's. So I'm going to bring that down here. I'm going to bring this right here. All right, so -1 times A is negative A. -1 times C is -1C. And 27 times -1 is -27. So I am combining. I'm not messing with this one right now. So 4A minus 1A is 3A. 1C minus 1C is 0. And 60 minus 27 is 33. And now to solve for A, I'm going to divide both sides by 3. So that means I had 11 adult tickets. And since originally the first equation was the number of adult tickets plus the number of children's tickets equals 27. So to get the number of children's tickets, I would subtract 11 from 27 and I would get 16. So 16 children tickets. So let's make sure it's right. Is 11 plus 16, 27? It is. If adults paid $4 each, that's $44. Children paid $1 each, that's $16. And that tells me that made $60, which is the other criteria we were trying to meet. So I know my answer is correct. All right, Farmer Brown. So Farmer Brown had 63 cows and chickens. Those 63 animals had a total of 74 legs. How many cows and how many chickens does Farmer Brown have? So you need 2 equations. One deals with the number of animals and the other deals with the number of legs. So we're going to let our X be cows and our Y be chickens. I just, chose those. There's no, reason, or you don't even have to use those variables, but don't use C and C to represent 2 different animals. So the first thing we're going to say is the number of cows plus the number of chickens equals 63. That's what it says right here. And now we're going to worry about their legs. So cows have how many legs? So we're going to multiply 4 times the number of cows we have, plus chickens have 2 legs. So 2 times the number of chickens. And in this situation will equal 174. And since I just prefer elimination, that's what I'm going to do. I'm going to eliminate my y just because I choose to do that. I could eliminate my x, but I'd have to multiply by -4. And I'd rather multiply by -3 to get rid of, -3. I'd rather multiply by -2 to get rid of my y's. So I'm going to take that original equation. I'm going to multiply every single term by -2. So I have -2x minus 2y equals -126. And now I'm combining these two equations. So 4x minus 2x is 2x. 2y minus 2y is 0. And 147 minus 126 is 21. Oh, that can't be. Oh, I can't have 170. Oh, what did I write? I wrote it backwards, you guys. I wrote 147. Were y'all yelling at me? Were y'all saying that's not right, Miss Richardson? I was confused for a minute. I'm like, how do we have odd legs? We can't have an odd number of legs. All right, so 14 minus 6 is 8, and 6 minus 8 is 4. Oops. Come on, eraser. We're almost done. Okay, here we go. So 48, does that look right, you guys? So x, half of 48 is 24. Well, 24 what? What does it say? Well, 24 is the number of cows. If we had a total of 63 animals and 24 are cows, that means we have 39 chickens. So we got 2 things to check. Does 24 plus 39 equal 63? It does. And if we have 24 cows times 4 would be 96 cow legs, and 39 chickens would have 78 chicken legs. Is that our correct total of legs? Well, 6 plus 8 is 14, and then 174. Yep, that's exactly right. So our answer is right here. We had 24 chickens and 24 cows and 39 chickens. So you will have a Farmer Brown question on your test tomorrow. So hopefully you guys understood that. We have a meeting on Wednesday at 10. So I'm going to just have that meeting in order to answer your questions. So hopefully by then you have watched this video and looked at your practice problems and worked them along with me. And if you have any questions or you need me to clarify anything, please come to Wednesday's meeting at 10 o'clock and we will discuss whatever you need before you take your test on Thursday. All right, guys, you guys have a great day.